Good evening, everyone. I welcome you all in a Sapience Education. So, for more details, you can visit our website www.sapienceeducation.com. Okay, sapienceeducation.com. Okay. Now, today I am going to discuss about gravitation. What is gravitation actually? Gravitation is what? So, before knowing about gravitation, we should try to understand that what actually gravitation means. See, when Newton's are when sit below the apple tree, so apple suddenly fall down. So and then he start thinking why it fall down only, why don't it went up? So the reason behind he started found and he formulated our very famous formula, that is F is equal to F, G m1 m2 by r square. Okay, so in this context we should also go through the definition, Newton's gravitational Newton's law, as well as how it act. Okay, now Newton's law of a gravitation, it states that every body in the universe attract every other body with the force which is directly proportional to their masses and inversely proportional to the square of the distance. Wherever you see any mass, right, wherever you see any type of mass, let us consider this is a mass m, this is a mass m2. So if any masses, two masses are present, so definitely there will be a force applied on a mass 1 by mass 2 and force applied on mass 2 due to 1. So force on a 1 due to 2, and this is your force on 2 due to 1. So every mass will apply a very equal force, and as per the Newton sir, he told that force is directly proportional to the product of mass. If mass is more, any of the mass is more, it means that force is more. So force can be no, called as a force is directly proportional to mass m1 and m2, that is product of the masses. Now again he have seen that whenever we start separating any two masses, separating, so what he saw that there is sudden fall of the force, and he observed that force is inversely proportional to the square of the separation between them. Okay, so this is second equation. So this time two dependency he has found out, and he combined this. Then what happened, we got F is equal to F is proportional to m1 m2 by r square. But here if you remove the proportionality constant, you will get gravitational constant G. G is universal gravitational constant. Why it is universal gravitational constant? Because it is applicable, in whole universe, anywhere you can apply this. Okay, so there will be no error at all. So this is very famous relation. So G has value that is equal to 6.67 into 10 power minus 11 Newton meter square per kg square. And if you go for a dimension of a G, so G has a dimension mass inverse L cube T minus 2. So this is all about Newton's law of gravitation. I hope you have understood now. So whenever they want Newton's law of gravitation, you should write this definition, okay, with the equations. Now if we discuss about the gravitational law of motion, or equation in the form of vector. So let us consider there is a reference axis, that is x-axis and y-axis. There is a reference axis x-axis and y-axis, and there are two type of mass present at here and here, and both have a mass. Let r1 and r2 be the displacement vector, or we can say that position vector. It is your position vector, right? Position vector. Okay, and m1 and m2 are the position respectively. M1 is the position, and the M1 has a position R1 and M2 has a position R2. Now the force F12 is the gravitational force exerted on a mass M1 by M2, and the F21 is the gravitational force exerted on a mass M2 by M1. Now if you want to find the formula that how you will find a force between these two forces in a vector form, and you have a position vector R1, you have position vector R2, you have displacement vector R12, and you have displacement vector R21. R12 means R is heading from 1 to 2, and R2 is R is heading from 2 to 2, 2 to 1. That is the main basic difference. So in this way you will able to determine how you will determine in a vectorial form. So let us see here. F12 is equal to G into mass m1 into m2 into m1 into m2 divided by r12 whole square into r12 cap. If you go for force F21, that is force on 2 due to 1, so you will get the formula G m1 m2 by r21 whole square divided by, into r21. Okay, I hope you have understood now. Now, important points. Some of the important points are gravitational forces are central forces as they act along the line joining the center of mass. So let us consider this is a two mass, so the force will always act toward the central line. So the line joining the center of the mass, that's why it is known as central force. Now it is conservative force. Why it is conservative force? As work done by this force does not depend upon the path. For example, you are working against the earth and you are not following any type of path you are following. It does not depend upon the path. It depends upon initial and final position. I hope I have discussed all this thing in a conservative force potential energy, right? So this is your conservative force. Now the total gravitational force or a particular particles due to many number of particles is resultant of a force of all attraction. What do you mean by this? See here, if you want to see here, let us consider this. If there is an object and there is many object, okay, so I want that what is the force, net force acting on this object due to this force 1 2 3 4 5 6. So total force acting will be equal to F1 plus F2 plus F3 dot Fn. So in this way you will able to find the total net force is the summation of all the forces acting on the body due to different type of masses. I hope you have understood now. Okay, I will provide you each and every note, so go for a document. No need to write, just you go through my notes for more details. Okay, now so it's the end of the gravitational universal law of gravitation constant. Now it's a turn of a Kepler's law of a planetary motion. So you are seeing that how an object is being moved from here to here, and it is moving in elliptical path. It is moving in elliptical path, right? And here you see that the longer distance, it is your long distance, but the speed is here, speed is low, and it is your shorter distance of planet, from sun. High is the speed, it means that if you will talk about elliptical path, see here, elliptical path, for example, every planet will move in a elliptical manner, and there are two focuses are present in any ellipse. So at one focus there is a sun, and at other elliptical path planet is moving, right? One thing you need to observe that as soon as it is in a very far away from the sun, so its speed is very slow, but as soon as it come nearby, so its speed become very high. Okay, so I hope you have understood now. Okay, now what is Kepler's law of planetary motion? See here, all planets moves in a elliptical path, okay, and they follow certain rules. So Kepler's give three laws. So first of all, the law of orbit. What is law of orbit? See here, law of orbit, you can understand the motion. See here, whenever this planet come near by the sun or one side of the focus, so what happen, its speed increases, right? But as soon as it become very far, so speed decreases. So these are the thing. So how they are behaving, and they, as per their behavior, so we need some law. So see here, every planet revolves around the sun in an elliptical orbit with the sun at one of the focus. See here, any ellipse, you will get two focus. Ellipse has two focus. Ellipse don't have a center. We consider two focus, right? And this is elliptical shape, right? So there are two focus on a ellipse, and at one any focus sun reside. So let us consider this is the part where sun is residing, and the planet revolve around the sun in the elliptical way. Okay, so this is known as the law of orbit. So this you need to remember. And see, again is your law of area. So let us consider law of area. The line joining the sun to the planet sweeps out equal area in equal interval of time. According to this law, planet will move slowly when it is farthest and will move rapidly when it is near to the sun. So just now you can understand. See here, when it is nearby, it is very fast, and when it is very far, it's move slowly. It moves slowly, such that at the same time, for example, if you consider this, see here, it sweeps equal area in equal interval of time. So I want to make you clear from here. See here, let us consider this is a time t1 and this is time t2. Okay, for t1 it is your 10 second, so within t2 also 10 seconds. So within 10 second, the area sweeping, this is the area of sweeping of the planet. So planet come from here to here, and here also planet come from this position to this position. So the area swept by this planet will be equal, right? Equal. So if we consider the area covered by the planet in the short interval of time, that is dA, if you consider that the area covered by the planet in a short interval of time, for example, that is dt. So can you see that this area appears to be in a form of a triangle? So this is equal to half into base into height. What is the base of the triangle? So base, this is the base of the triangle, and height is your radius, right? Height is your radius. But you see here that here radius is different. Here radius is, suppose here radius is r2, here radius is r1. So radius is varying, right? Radius is varying. Now can we write here base means what? This length. So if it has certain velocity, so can we write here velocity into dt into r? R is the height of the triangle. See here, this is the r. So in this way we can approximately write area dA as like this. So if we write this, can we write here like this? Now can we see that dA by dt is equal to 1 by 2 into velocity into radius. And as per this law, as soon as velocity increase, it means radius is decreasing. Just now I have shown you. See here, here velocity is very high, so radius is less. Here velocity is very less, so radius is very large. Understood? So this thing you need to understand, right? So but they both increase and decrease in such a way that the product is constant. That is, if v will increase, then to compensate this, r is to decrease. If v will decrease, then radius should be increased. In this way, see here that aerial speed means area swept per unit time will be constant for entire revolution. This is what law of area is. Okay, so see here, from this you can see, imagine that every equal interval of time it is sweeping an equal area. So this is the law of area. Okay, now next part is law of periods. What is law of period? See, a square of a time period of a revolution t time period, let us consider T is the time period of any planet. Okay, T is the time period of any planet. That is, it requires time period is what time required to complete one revolution of any planet around the sun is directly proportional to the cube of the semi-major axis of the orbit. So what is semi-major axis? What is semi-major axis? So let us consider. See here, this is the sun. Can we write here? This is your R1 and this is your R2. So if we this is R2 is your R maximum and this is your R minimum. So if you want a semi-major axis, so what is a semi-major axis? So say this is R is known as R maximum plus R minimum divided by 2, and this is called semi-major axis. So as per it, time period of a revolution is square of time period of the revolution is directly proportional to the cube of the semi-major axis. So if you remove the proportionality constant, you will get Ks, and Ks is known as Kepler's constant. And what is the actual values of a K? K is equal to 4 pi I square by G into ms, where ms is the mass of the sun. I hope you have understood. And G is your gravitational constant. G is your gravitational constant, right? Gravitational constant. I hope you have understood now. Okay, so you can see, you can feel whatever law I have taught you. You can feel here. Here it is your, see here, it is slow, it is high speed, radius is large, radius is small. Okay, now as soon as radius increase, for example, this is your earth is revolving. If Pluto is there, so time period of Pluto is very high, because as soon as R increase, so time is also increasing. So the relation between time period and the radius or semi-major axis is equal cube of the semi-major axis. I hope you have understood now. Thanks for watching my video, and if you want more videos, please subscribe our channel, and I will give you more and more video. And if you want, then please comment in the given below section. Thank you.